All right, everybody. Today we are going to be talking about quadratic functions and their graphs and some key features of these quadratic functions and their graphs. So a quadratic function in standard form looks like y equals ax squared plus bx plus c. Now sometimes it doesn't have all of these parts, but for sure it will always have an x squared. So we call the parent form of this y equals x squared if it's just those, and then if other additional pieces a, b, and c are there, it has more features. Now our leading coefficient we learned in our previous unit is a, so the number at the very front in front of x squared is going to be a. Sometimes it's just 1, so we don't see it, but sometimes it'll be other numbers. And then the number at the very end, c, is going to be our y-intercept, which is where we cross the y-axis. This is always going to occur when x is equal to 0. So 0, comma c is the location of the y-intercept where the graph crosses the y-axis. Now, our quadratic functions are going to have solutions. Now, solutions has some other names that we sometimes refer to it as. These all are referring to the same place, the same solutions. Sometimes they're called roots, or zeros, or x-intercepts. These are all referring again to the same place. So on something like the STAR test, you may have one question that refers to zeros and another question that refers to solutions, and they're talking about the same thing. So these are all the same. Now we're going to talk about some of the characteristics of the graph of a quadratic function so that we can identify information just based off of the graph, as well as it kind of helps us find some additional pieces of information. So the very first thing is that we want to remember is that a quadratic function is a U-shaped graph called a parabola. So it could go open up to the top like a U, or it could open down to the bottom. So think kind of like a rainbow, the different directions, or a horseshoe. That works as well. Now our parabolas, no matter what, are either going to have a minimum or maximum. The minimum would be the lowest point. The maximum would be the highest point of the U. So it depends on if it is facing an opening up or opening down. So it depends on the direction. So I have two parabolas here that are graphed. Looking at the one on the left, if a, which is our leading coefficient, is positive, if it is a positive number, so it says you don't see a negative in front of ax squared, it is going to open up like a U, and it will have a minimum. It will have a minimum. So this low point down here at the bottom is the minimum. And if our leading coefficient is negative, so if a is negative, so it says a negative in front of ax squared, it will open down. So more like a rainbow, and has a maximum. So meaning it has a high point. So here is our maximum. Now what we also have to keep in mind is all of our parabolas will have what we call a vertex. And that vertex is the lowest point or the highest point of the parabola. So it's where that minimum or maximum is. So With the parabola on the left, where that minimum is, that is also going to be our vertex. And with the parabola on the right, that high point where that maximum is again also going to be called the vertex. It's the vertex for both. It's the peak of the high point or the very lowest of the low point. Now that vertex also provides us with a line that vertically passes through the graph. That line passing through the vertex divides the parabola into two symmetric parts, and that is called the axis of symmetry. And this is again going to be a vertical line. So it's going to go up and down. So if I look at my two parabolas, that vertical line is going to come, and I'm just going to use a dashed line to show it, is going to come down right through the vertex for both of these. And if you imagine folding the graph across that dotted line, it will perfectly fold it in half. So again, you're going to have some sort of dotted line, and the going through the vertex, and the graph will hold up on both sides. So let's see if we can identify some of the features on our graph. Some of these will be new, some of these will be things we have just discussed. So starting off with the vertex again is going to be the highest or lowest point, depending on where kind of the bump of the U or of the rainbow is. And so that is going to exist here. So this is our vertex. It also would be your maximum or minimum, depending on what the graph looks like. Our axis of symmetry is again going to be that vertical dashed line. Axis of symmetry. Our y-intercept is where we cross the y-axis, and that is going to be right here. And then lastly, our zeros. What we want to remember about zeros is it is another word for, so AKA, also known as x-intercept, roots, or solutions. All of these are the same thing. You could have 1, 2, or 0, like none zeros. Let's do the number 0. So if I look at this graph, I have two spots where we are crossing the x-axis, so I have 2 zeros or 2 solutions. And again, these are all referring to the same spot. So zeros, roots, solutions, x-intercepts are all referring to that same spot.